Right, here's another momentum problem that's worth examining. Let's imagine we have a cannon and a cannonball. That's in diagram 1. If you notice they're stood still there, there's no velocity. So the momentum there is 0 because the velocity is 0 and momentum is mass times velocity. And if your velocity is 0 and you multiply anything by 0, you'll get the answer 0. Then what happens is the gun fires and the cannonball goes to the right, and the gun, you probably know, will recoil to the left. Now it is possible to predict as to at what speed these things will recoil at. So let's imagine that we worked out that we knew that the ball travelled at 20 kilograms. The ball had a mass of 20 kilograms, and the velocity of the ball was 400 meters per second. We are told also that the mass of the cannon is 2,000 kilograms. What's the velocity of the cannon going to be? So for this, we need to start using the physics equations that we had before. So the momentum before equals the momentum after. Let's look at the momentum before. Now that's before the cannonball's been fired. Now you know that the mass of the ball is 20 kilograms. The velocity of the ball is 0. So 20 times 0 is 0. You know that the mass of the cannon was 2,000. And the velocity of the cannon before it fired was 0. So 2,000 lots of 0 is 0. So the total momentum before was 0 kilograms meters per second. And that's because it wasn't moving. So after the event, the momentum must also be 0. Okay? So momentum before is 0. Momentum after is also 0. And what we're doing here is looking at trying to work out what the velocity of the cannon is going to be after it's fired. So this time, if we look now at the third line down, we said 0 equals 20 times 400. 20 is the mass of the ball. 400 is the velocity of the ball. So 20 times 400 is 8,000. You can see that beneath. Plus, now you look at the momentum of the cannon. It's 2,000 kilograms times the velocity of the cannon. Now we don't know what the velocity of the cannon is, so we just put down VC. So underneath it, you see written down 2,000 VC. Now, so I've got at the top now, I've got 0, which is the momentum before and also the momentum after, equals 8,000 plus 2,000 VC. Now, what I do there is I try to get the VC by itself. So I've subtracted 8,000 from both sides. So I get minus 8,000 equals 2,000 VC. If I divide both sides by 2,000, I now get minus 8,000 divided by 2,000 equals VC. I've got rid of the 2,000 VC by dividing it by 2,000. And of course, minus 8,000 divided by 2,000 is actually minus 4 meters per second, which is what you see at the bottom there. We have worked out that the cannon recoils at speed of minus 4 meters per second. Now, I guess you're probably thinking, what does minus 4 mean? Well, the fact it's minus tells us it's going in the opposite direction to the cannonball. The cannonball's got positive direction. The cannon has got a negative direction. The whole calculation's there in front of you, so you can try to work it out. What I've done there for you also is I've actually created another problem for you to calculate there. So we go to problem 2. You've got here, you need to calculate the speed of the rocket. And how can you do that? Well, you're told the mass of the rocket is 1,000 kilograms. The mass of the exhaust, the thing coming out the back of the rocket, is 100 kilograms. So that exhaust gas weighs 100 kilograms. The velocity of the exhaust is 5,000 meters per second. That's the speed at which the exhaust gases are coming out. What's the velocity of the rocket going to be? Again, to give you a hint for this, you have to imagine what the rocket was like before it fired. I'll give you a clue. The velocity of the exhaust and the velocity of the rocket was 0. So the total momentum before it launched was 0. And then if you start looking at working out the momentum of the rocket after the launch and the momentum of the exhaust gases after the launch, you should be able to use the same principles we did in the first problem to work out what the velocity of the rocket is. If you want to pause it here, you can. Let's try to do some calculations. The answer is going to appear in about 3 seconds. 3, 2, 1. The answer is there, minus 500 meters per second. And that there are more momentum problems. This again would be the A-star question. This is a very, very tough question.